Hi again. Okay, so this is about where I left off. Figuring out that you need to sell 40 bracelets to make a profit of $700. But I did want to also mention that I kind of forgot to put a title for this graph. So you do want to make sure your graphs have titles. So I would just call this something like Michelle's Bracelet Business or something like that. But once I have that, then that looks pretty good. So that is number 16 for you. Okay. Now number 17. So we're given that y equals x is the parent function for any linear equation. And that's always true. Y equals x is the parent function anytime you have a linear graph. So there's like 3 different ways that you can transform linear functions, right? You can dilate them, so that's changing the slope. So any number that you put in front of x will change the slope. If that number is greater than 1, it's going to stretch the slope, it's going to make it a steeper slope. If it's a number that's a fraction less than 1, then that is going to compress the slope, or compress the graph and make the slope more gradual. So, like looking at the first one, we have y equals 3 times x. So that is changing the slope, because it's changing what's in front of x, and it is multiplying it by a number greater than 1. So it's going to dilate, it's going to make the graph steeper. By a factor of 3. So this is an example of a dilation of the graph. Now, you can also have translations. So translations are when you shift the graph up or down. So that's when you have a number like it's the b value, it's the y-intercept. Whenever you have a y-intercept that's different than 0, that is a translation. So you're either shifting it up or shifting it down several units. And then the third option you can have is a reflection over the x-axis. So that takes a positive slope and it makes it negative. So anytime you have a negative out in front of the x, then that is a reflection over the x-axis. So if we look at letter B, we have a negative here in front of the x. So that's going to reflect or flip over the x-axis. And then this -1 here, that's changing the y-intercept. So that's taking the graph and it's just shifting it down 1 unit, or translating it down 1 unit. Oops, sorry, 1 unit. So this is a translation. So again, you have 3 options. Dilation, changing the slope, translation, changing the y-intercept, and then reflection, making the slope negative. Something like that. Okay, so next, kind of skipping ahead, I want to look at number 19. So this is an example of a linear regression problem. So it has the rice produced in Texas from 2001 to 2007. So it wants you to use x being the number of years since 2001. So that means when you go into your stat in your calculator and you start at list 1, your first value should be 0 because 2001 is 0. And then you go up as like how many years since 2001. So 2002 is 1 year since 2001, so next is 1 year. And then 2003 is 2 years, so then we have 2. And then 2004 is 3 years, so then so on and so forth up until 6. So I have this data entered into list 1 and list 2. So once you have all of that typed out, you're going to go ahead and hit F2 for calculate, and then F3 for regression. And we want a linear regression, so that's F1. And then if it comes up again, you're going to hit F1 one more time for AX plus B. So we see now that our linear regression is 0.11 is the slope, so that's 0.11x, and then plus 0.4, and we would round 0 up to 1 because of this 5. So then that's plus 0.41. So, oops. Y equals 0.11x plus 0.41. Now it says, using your linear model, predict the value of rice in Texas in 2015. So they're giving us the year, so that means that this is the X value, right? Because year is X, and then the price per pound is Y. So I'm going to have something I'm going to plug in for X, but I don't want to plug in 2015. I have to remember that my X actually represents how many years since the starting year, which in this case was 2001. So I take 2015, I subtract 2001, and I see that that is 14 years since then. So I'm going to take my linear model, and I'm just going to substitute 14 in for X. And when I do that, I get Y equals $1.95, and that's per pound. And that would be my final answer there. Now part C says to use the linear model to predict when the price is likely to reach $2.60 per pound. So this time they're giving us the cost, or the price. So in this case, it is the Y value equaling 260. So I'm going to plug 260 in for Y, and my goal is to solve for X. So I have to subtract 0.41 from both sides. When I do that, I get 2.19 equals 0.11x. I divide by 0.11. And I'm left with x equals, so when you divide that out, you get 19.9. So now, that doesn't mean that in the year 19.9, or in the year 19, the price was $2.60. That doesn't make any sense. What that means is it's 19.9 years since 2001. So we take 2001, add 19.9, and we get 2020.9. So that means that in the year, during the year 2020, so probably sometime in November or December, right, because it's 0.9. If you think about being 90% through the year, it'd be in like November or something like that. So it would be in the year 2020 would be when it would reach that price. So that's how you would do a problem like number 19. And I like this problem because it has both one example where you have to plug in the x, because they give you the year, and then there's another example where you need to plug in the y, because they give you the price per pound. So I think that's a pretty good example. Okay, and then that is about all for Unit 2, and then I just want to go through a few of the spiral reviews, just because these are going to be on your test. Toward the end, there's just going to be a few problems there, and I want you to kind of hopefully do pretty well on that. So remember, we don't want any negative values in our final answer, so everything should have a, I'm sorry, there can be negatives, there just can't be negative exponents. I'm not sure if I said that right. So we don't want any negative exponents in the final answer. So let's just start from the beginning, go through a few of them. So if we have something being cubed, we have to follow the exponent rules. So this 3 has to sort of go to each factor in that parenthesis value there. So I have to cube 4, and I also have to cube a squared. So I have 4 cubed. So I multiply these, so that becomes a to the 6th, and then I have x cubed. Now 4 cubed I can actually do. That's 64, and then I have a to the 6th, x cubed. I can't combine those, they're different variables, so that would be my final answer. Now number 5 is a little even trickier. Sorry, I'm kind of going out of order, but going across to number 5. We have to make sure we do order of operations. So after parentheses, which are like done, we have to do exponents. So this 7 and this a to the 4th have to be squared before I multiply them by the 2. So I have 2 times 49, that's 7 squared. I multiply the 4 times 2, and I get a to the 8th. and then I have that times a cubed. So now is where I can multiply the 2 by the 49. So this gives me 98, and then I have a to the 8th times a cubed. So when I multiply powers with the same base, I add the exponents, and so that becomes a to the 11th. And that would be my final answer. So do not, I repeat, do not do 2 times 7 and get 14, a to the 8th. That would be incorrect, and yeah, so just don't do that. Going on to number 2. So whenever you have a 0 on the exponent, that's just, that whole thing just turns into a 1. So you can basically just kind of ignore it. Then we have y to the negative 4th and y to the 4th. So if we actually think about, we're multiplying those, if we add those exponents, we have y to the negative 4th and then that negative 4 plus 4. So those become y to the 0. So that actually also cancels out. These two cancel out when you add them together. And then, really, all we're left with then is just z to the 5th. That's my final answer. Number 6, let's look at that one. So we have 8a to the negative 2nd, b cubed, c to the 6th, over 12b to the negative 3rd times c. I personally like to get rid of negative exponents as quickly as possible. And I also like to take care of my fraction as quickly as possible. So the coefficient, notice we have 8 over 12. So what we want to do is just reduce that. So both of those can be divisible by 4. So this can become 2 over 3. Now I took care of my coefficients, great. Now anytime I have a negative exponent, they're just going to switch, they're going to jump across the fraction line. So a to the negative 2nd is going to jump down here and become a to the positive 2nd. b to the negative 3rd down in the bottom is going to jump up to the top and become b to the 3rd. But there's already a b to the 3rd in the top, so that needs to stay there. And there's a c to the 6th. And there's also a c down here. So that's one step, okay? I'm not done, but that's like a step in the right direction. So now I have 2/3. And then I have b cubed times b cubed, so I'm going to add those exponents. So 3 plus 3 is 6. I have an a squared in the denominator. And then I have c to the 6th over c. Remember, if you don't see an exponent, that means there's an invisible 1. And when I divide powers with the same base, I subtract their exponents. So I'm going to take 6, subtract 1, and get 5. And so I have c to the 5th up there at the top. And so that would be my final answer for that one. So the rest from there are pretty similar. So I'm thinking you can figure this out on your own. I don't know why this is missing a variable, but there should be an a right. Oops, sorry. There should be an a right there. But yeah, hopefully this was helpful. Good luck on the test today. You'll do great. Just, yeah, remember everything you did. Keep your eyes on your own paper. Do your best work. Things I always say. But yeah, and then enjoy your weekend. And I will see you when you come back on Tuesday, I guess that would be. Yeah. Okay. Well, yeah. Have a good day.